Alright, so the hard part of 41 is actually finding the moment of inertia. Once you find that, then the angular momentum is pretty straightforward. So let's just do the part A first. So we got a sort of square shape that pivots about this axis, swings around like a door. And we got a circular shape, it also pivots about that axis. This is R. And this is R. So, first thing to notice is this piece is actually no distance, a distance of 0 away from the pivot or the axis, so that this edge of the square contributes nothing to the moment of inertia. And all of this mass is the same distance away. So you could treat this like a point particle with all the mass right at the center here. And then these are pivoting rods that will have to use a parallel axis theorem because they pivot here and not at the centers. And then this one's just straightforward. So the I of the right square piece is 0 kilogram meters squared. The I of the left straight piece, this one, is just mr squared because you can treat it like a point particle. And that's just going to be, the mass is 2. The r length is 0.5 squared. So that equals 0.5 kilogram meters squared. Not too shabby. That's an L, not a 2. Then each of these have the same, so we can just double that later. So we'll just say the I of the horizontal bar pieces is parallel axis theorem. You've done enough of these when you pivot at the end to know that it's 1/12 plus 1/4. Anyway, it turns into 1/3 mr squared. This combines both the center of mass and the parallel axis theorem. And that's just going to be 1/3 times 2 times 0.5 squared. And that is 1/6 kilogram meters squared. So the I of the whole, all four, to make the square, is this plus 2 of these. So that becomes 5/6. You can add those up pretty quickly in your head, hopefully, or on a calculator. Kilogram meters squared. That's the I of the square. Now the I of the circle, you can look up on the table, that is 1/2 mr squared. And then the parallel axis theorem, since it doesn't pivot here, it pivots over here, you have to do plus m, and then it's r again. It's r away. Right? That's r. So that just becomes 1/2 times 2 times 0.5 squared plus 2 times 0.5 squared, and that equals 0.75 or 3/4 kilogram meters squared. So what's I total of this whole shebang? 5/6 plus 3/4 equals 19/12 kilogram meters squared, which also is in decimal form 1.5 0.83 kilogram meters squared. And that's it. Either of these is fine. That's part A. Part B, we needed to find the angular momentum. That's just I omega. We found I, so that just equals 19 over 12 times omega. 12. What's omega? Omega is theta over time. This is just a constant speed, so no acceleration, so that's what it is. We don't need kinematics really, although this technically is kinematics. And it's period, which means it goes around a circle once, so that's 2 pi radians around once, and then it takes 2.5 seconds to do that, so that is just 4/5 pi. So this equals 19 over 12 times 4 over 5 pi, which equals 19/15 pi. A little bit of fraction magic. Kilogram meter squared per second, or if you like the decimal form, 3.979, basically 4, rounded to 4 kilogram meters squared per second. Either of these is fine. Cool. Alright, next problem.